Good morning, students. This is a class for optics or light of class 10. Today we will learn refraction of light through prism. Now you all know what is prism. Prism is a 3D object. It's a transparent medium made up of mostly glass. It has a shape like that. I tried to draw a 3D shape of prism. It has 1, 2, 3, 4, 5 surfaces. You can see 2 slanting surfaces just like the top of a heart, 1 base, and all these 3 surfaces are rectangular in shape. You could find this is like a trapezium, but it's just the perspective of a 3D object. That's why I have drawn it like that in order to make it appear as a 3D object. So it has got just 2 slanting rectangular surface and 1 surface at the bottom. The bottom surface is also rectangular, you can see it. And this surface is called base. These 2 slanting surfaces are actually the main surfaces where the prism refracts light. So these are called refracting surfaces, and the angle between the 2 slanting surfaces are called prism angle. This is a characteristic angle of a prism, because depending on that very angle, prism can deviate light more or less. So here it is a 3D shape of a prism, but whenever in our geometrical optics we will draw the ray diagram. When the ray passes through the prism, we have to draw the diagram. We will draw a prism like a triangle. It is called the schematical figure. So this is the schematical figure of a prism. It is just a triangle. This is a leveling arrow. This is not a part of a prism. This is a leveling arrow. We just draw a triangle in order to signify or in order to represent a prism. And these 2 slanting arms represents the 2 refracting surfaces. These are actually the refracting surfaces where the light enters and emerges out from the prism. This angle is of course the prism angle. What we have said, it is a very important angle and the most characteristic angle of the prism. And the baseline actually shows the base, that means base surface of the prism. So this is the schematical figure of the prism. Now why do we read prism after completing lens? Because in the last chapter we have completed lens, convex lens, concave lens, and the ray diagram. Now we are about to start prism. Why we are reading prism? Because prism is also a refracting medium, and we are actually reading the topic refraction of light. So light could refract through any medium which is transparent and which have different optical density from the first medium. In most of the cases, prism is made up of glass. Now while light traveling through air or vacuum, when it enters into another medium like glass, water, it could refract. It bends its original path, it bends from its original path and passes through the second medium. Now what happens when light enters into the prism? Let us see. This thing seems to be very sticky in the board, leaving its impression. It's not supposed to have. Let us try to remove it. Okay, almost done. So what we are about to see, what happens when light enters into the prism. I'm just writing as a note. You can write it down in your paper. Two things could happen. You know, there are two types of light. First is monochromatic light. And another is polychromatic light. Monochromatic light means single color or single frequency of light. That means a light which contains only one frequency. Actually, each color has different frequencies. We know there are 7 colors in a rainbow: vibgeo, violet, indigo, blue, green, yellow, orange, red, and each color corresponds to different frequency. Actually, it is in the decreasing order of frequency. Violet has the highest frequency and red has the lowest. In fact, frequency and wavelength are inversely proportional to each other. When frequency increases, wavelength decreases. So, red has the highest wavelength and violet has the least wavelength. Now, each color, suppose yellow. Yellow has a particular frequency of 5890 or whatever like that, 86 angstrom. So this particular frequency corresponds to only yellow light. Now when you have a light which is purely yellow, you can see there are lasers in the market, and lasers could emit a single frequency color. Often it is available red torch or red lasers, and these lasers are actually producing monochromatic light. I have one, I can show you. So whenever I give this color on the board, you can see the color of the light is entirely red because it is only producing a single color, which is red. Now the light which has only a single frequency, here the light has only a single frequency, that is the frequency of red, which is least among all the 7 other colors. This type of light is called monochromatic light. Now what is polychromatic light? Mono means one and poly means multiple. So polychromatic light is something which has got more than one color. So light containing more than one color, like more than one color, or color means more than one frequency, more than one color, or more than one frequencies. This type of light is called polychromatic light. Example, the light we are having on the board is a light coming from the tube. It's a white light. Now you can see that after the rain, when sunshine falls on the sky from behind, from your back, the droplets in the water vapor and the droplets that are floating on the sky, they refract the light and produce a rainbow. So there are 7 colors that are coming from the white light. Hence we can say that a white light has 7 different colors. One thing we can also, by one experiment we can also prove there are 7 colors in a white light. and that thing was actually described by Newton, and it is called Newton's ring. What you can do, you can take a disc, then you can divide in 4 parts, and each part you can draw 7 colors sequentially: violet, indigo, blue, green, yellow, orange, red. You have to repeat this thing in each quadrant of the circle. Now, when you have finished doing that, then what you have to do? You have to rotate the disc. Somehow you can use a motor. You can fix it on the ceiling fan and switch the ceiling fan on. What you will observe? You cannot see different colors over there. Instead, you will see the white color. The ring will appear white then. This is very easy example and experiment. You can do it in your home. And this thing proves when all the colors merges with each other, put their impact on your brain at the same time, allowing it to mix in your brain. So after mixing all this color, you will get a white light, which proves a white light is a polychromatic light containing 7 colors. Now, you might have one confusion. Students, you can do one thing. You can take your color box and mix all the colors all together. Violet, indigo, blue, green, yellow, orange, red. You have just rubbed on your page one after another, sequentially. And you will find, instead of coming white, it is turning black. Actually, mixing your color on a paper is not the mixing of light. It is actually filtering the light. The thing we will discuss later, but you just remember one thing right now, is that whenever you have to mix light, the light has to merge on one another, not the color on the paper. Two things are different. So, we know there are 2 types of light: monochromatic light and polychromatic light. Monochromatic light means single color or single frequency, and polychromatic light means more than one color having more than one frequencies. So why do we define these 2 types of light over here in case of prism? Because when monochromatic light enters into a prism, when monochromatic light enters into a prism, it bends towards its base while emerging. From opposite face or opposite surface. But when polychromatic light enters in a prism, it gets splitted in 7 or whatever the constituent colors, in 7 constituent colors, and also they bend towards the base. So this is the difference between monochromatic light entering into a prism or polychromatic light entering into a prism. But in our syllabus, both are included. But right now, as we are in this chapter, refraction through the prism, we will only learn the monochromatic light entering into a prism. And the polychromatic light when enters into a prism, this thing is called dispersion of light. We will discuss it later in the other topic. This dispersion is also included in our syllabus. So we will do it in the next class. Today only we will learn what happens when monochromatic light enters into a prism. So we know what happens when monochromatic light enters into a prism. It gets refracted and ultimately it bends towards the base. So let's see how it happens and draw the diagram of that. In order to do that, we need to know different names of light rays which enters and emerges from the prism. So let us draw a schematical figure of a prism. Say this is a schematical figure of a prism. This is the base, and this is the most important angle of a prism, which is called prism angle. The alphabet A signifies both the vertex and the angle, or prism angle, I could say. Now, these two are refracting surfaces. Let a light incident on the prism just like that. So, what we have to do? We have to follow the rule of the refraction. It is air, that means rarer medium, and that is glass, so it's a denser medium. So whenever light enters from rarer medium to denser medium, what happens? Light comes closer to the normal. So where is the normal? Let's see where is the normal. Let us draw the normal. Normal means a perpendicular drawn on the surface. So this is a perpendicular drawn on the surface. You can write the name of the prism. Say I am writing its name ABC. So AB represents the refractive surface, and this red line represents the normal upon that surface. So the light should travel or will travel if in this direction if the prism were absent. So this is the direction of the incident light if the prism were absent. But since the prism is present and it provides a denser medium in the path of the light, so the light will bend towards the normal. So light ray bends towards the normal. It has bended. So from definition, this is angle of incidence and this is angle of refraction. The angle made by the incident ray with the normal is called angle of incidence, and the angle made by the refracted ray with the normal is called the angle of refraction. Now after refracting, it reaches to the next surface and incident on the next surface with certain angle. What is the angle? In order to find the angle, we again have to draw the normal. That means the perpendicular. So this is the normal, and the angle with the normal is the incident angle in the second surface. Now here in the second refraction occurs. This is the first refraction, this is the second refraction. So in case of the second refraction, what we see, light ray travels from denser to the rarer medium because there is also air outside the prism. So light ray is getting out from the prism and it is going into a rarer medium, so it has to go away from the normal. It may have traveled in this direction if this change in the surface was not there, change in the density of the medium was not there. But since there is a rarer medium, after that surface, it will go away from the normal, it will go in this direction. Since it has to go away from the normal, and this will be the second refracting angle. So ultimately what we see, that the light has eventually bent towards the base. This is the base, and light has eventually bent towards the base. That is what we have written in the previous sprint, that whenever monochromatic light enters into the prism, it will bend towards the prism. Now see, there are certain names of these rays. I can write the name of these rays. This is called incident ray. So what is the ray in the intermediate part of the prism? Inside the prism, it is called refracted ray. Refracted. So this ray is called refracted ray. And the ray which comes out from the prism is called emergent ray. So there are three different names for the rays: incident ray, refracted ray, and the emergent ray. And there are more than one incident and refracted angles too. You can see there are two incident angles and two angle of refraction. So let us write the names. Let us writing the names. Let us signify the first angle of incidence by I1, first angle of refraction by R1. Second angle of incidence is I2 and angle of refraction is R2. Now here is a confusion you might have got. Why I have put I2 over here instead of this angle? Because it appears that the light has incident from this side, so that must be the angle of incidence and that must be the angle of refraction. But I have written just in the reverse direction. I have written the angle of refraction inside the prism and angle of incidence outside the prism. Why? Actually, this is nothing but a representation or nothing but a variable you have to choose. Just imagine you can take any unknown variable by x, or you can take it y. You can take it even a, b, c, whatever you want. So it is just a variable. Whenever it comes in a value, the value is fixed. No matter what we write, I2 or R2, the angle will remain the same. First thing. And second thing, there is a significance between telling this angle, second incidence angle, is that it follows from optical reversibility of light. Optical reversibility of light tells us if we drive the light from the opposite direction, what happens? The light actually travels along the same path and returns to the same origin or source after following the same number of reflection or refraction that the original light or the incident light would have or has suffered. So no matter whether I am driving this light or sending this light from the left side or from the right side, the path of the light will remain same. So the optical reversibility actually allows us to send the light from the opposite direction and having the same ray diagram. That is why we can be able to send the light from this direction, and then this angle will be the incidence angle. So the ray diagram is drawn in such a way, or the nomenclatures or namings are given in such a way that in both sides we can enter the light into the prism. That is why it is written I2. So it is very customary. You don't have to find any reason behind it. It is actually given, or the representation is actually given for the convenience of mathematical ease, nothing more than that. So this is all about the ray diagram of a prism. After having the ray diagram and after knowing what is what, now we will find the amount of deviation that occurs when light travels through a prism. So what we will learn now? We will learn the amount of deviation. Now what do we mean by deviation? Deviation is actually, it is named angular deviation. So we can write it also angle of deviation. Angular deviation or angle of deviation, what does it mean? It actually means the angle between the direction of incident ray and the direction of emergent ray. So what does it mean? Actually it means what is the amount of deviation, means what is the amount of angle that the light has suffered after passing or going through the prism. What was its initial direction to go, and finally in what direction it has gone. The angle between these two things, these two directions are actually called angle of deviation. Now in this figure, if we want to exhibit the angle of deviation, I am just erasing some things which are not so important in this part. What you will do, you will pause the video over here and redraw the thing totally, and then find the angle of deviation in a mathematical or analytical form. So I am just using the advantage of the board, since I can rub it out. So this is only the ray diagrams which is left, and you know the name of the rays now. Now what we have to draw is the direction of the light. So this is the direction of the incident light. This is the direction of the incident light. The incident light will go in this direction, or should go in this direction when the prism was absent, and this is the direction of the emergent light. So if we produce it in the backward direction, we need to produce it in the backward direction. You have to find the angle between these two directions. So we have extended the emergent ray in the backward direction so that it intersects with the direction of the incident ray, and the angle, you see an angle is there. This is the angle between the direction of the incident ray and the emergent ray. This angle is represented by delta, and delta is called angle of deviation. So delta is called angle of deviation. We can give names of these points so that geometrically we can find the value of delta. Now we have to find the value of delta. This is our goal or target. Let this point, these are certain points which we have to name. They are the points, and one thing we can do, we'll just connect these two normals with each other. So that is another point. Now I am naming those points. Say ABC is done. So it is D, it is E, it is F, it is G. Okay, and later this is H. So what we have to find? We have to find delta. Let us find the value or mathematical expression of delta. Look in this figure. From this figure we can see what is delta. Delta is the angle FGH. Delta is the angle FGH. Now that angle FGH is an external angle to the triangle DGF. Now, as we know that the external angle is equal to the sum of the two internal opposite angles. So what are the internal opposite angles? These and these are the internal opposite angles. These and these means, so we can write angle FGH is actually equals to, this is the external angle and opposite internal angles are DGDF plus angle GFD. What are the values of these two angles? Look at the figure. You can tell by yourself. Look, this total angle is I1, this angle is R1, and that total angle, angle GDE is vertically opposite to the incident angle. So angle GDE is actually I1 and this part is R1. So the remaining part is I1 minus R1. Have you got it? You can rewind the video and learn properly if you can't follow. Similarly, I2 and this total angle is vertically opposite angle, and if we subtract R2 from I2, we'll get this amount, this small amount of angle. So it will be I2 minus R2. So if we write these values here, we have I1 minus R1 plus I2 minus R2 means I1 plus I2 minus R1 plus R2. What is that? This is delta. So we have an equation for delta which involves two angle of incidences and two angle of refractions. Now we can measure the angle of incidences since it is outside of the prism, but we cannot measure R1 or R2 because these are two angles which produces inside the prism. We cannot measure those two angles. So these two things are unknown to us. We need to find or we need to convert this unknown with certain known value. So how can I do that? Let us see. Let us try to find the values of R1 plus R2 by any other means. Suppose we are just giving a name of this angle. Let this angle is theta. Let DEF be theta. Just letting it, because it is difficult to always write the total name, so I am giving a small name. Angle DEF is theta. From triangle DEF, let me just check whether you can see the bottom of the board or not. Okay, marginally. So from triangle DEF, we can write R1 plus R2 plus theta is equals to 180 degree. No? R1 plus R2 plus theta 180 degree. Therefore, R1 plus R2 equals to 180 degree minus theta. Okay? So, we have another equation which gives the value of R1 plus R2 and which is equal to 180 degree minus theta. Again, there is an unknown value. This unknown value, we don't know what is the angle of theta, because it is also an intermediate angle. So let us take another equation. Now I will have to wrap certain. Okay, I am writing the next part from here. So after this, let us start from here. Again, you can see there is a quadrilateral ADEF. From quadrilateral ADEF, the sum of the four angles is always 360 degrees. That was known from geometry. What are the sum of the angles? What are the angles over there? FAD plus angle ADE plus angle DEF plus angle EFA means 360 degree. Now let us put the values of all these angles. What are the values of these angles? Let us see. Let us check. FAD is the prism angle. I have previously told that prism angle is defined by A or represented by A plus ADE. Look here. This red line is a normal. So ADE is obviously a right angle, 90 degree. So 90 degree plus DEF. Where is D? DEF is written as theta. We have named that. And EFA, another normal. So it is also 90 degree. So 90 degree. That is also 90 degree. The total angle is also 90 degree. So it means 360 degree. So from here, from this equation, you can see 90 plus 90 180 degree. 360 minus 180 is 180 degree. So what you can write? 180 degree minus theta. We have taken all this thing in the left side, or we have just brought the 360 degree in the right side, and we have 180 degree minus theta is equals to A. So this is the equation number 3. From 2 and 3, what we see? From 2 and 3, what do we see? 180 degree minus theta is A, and 180 degree minus theta is R1 plus R2. So R1 plus R2 is actually equals to A, the prism angle. The prism angle is known one. It was provided by the manufacturer of the prism, and it is very important angle. Why important? Because now from equation 1, putting this value 4, say this is equation 4, putting the value of equation 4 in equation 1, what we have, putting the value of equation 4 in equation 1, putting value of 4 in 1, what we have seen, delta is equals to I1 plus I2 minus, instead of R1 plus R2, we will write A. So this is the actual form, or this is the form of deviation of light produced in a prism, and here all the values, all the variables are known. I1 we know, I2 we know, and even A, which is actually substituted by is the substitution of R1 and R2, is also known, because if that was provided, that should be provided by the manufacturer of the prism. So this is the total derivation of deviation, angle of deviation produced in the prism, and it is very important derivation in terms of exam. In alternate years, you can find this question in a question paper to find the deviation produced in a prism. So you need to write this, all this thing and the geometry in such a way so it can exhibit the total logic behind the geometry. And also you must draw the diagram quite neat and clean and with a bigger space, so that these things doesn't appears clumsy. So this is what we called angle of deviation in case of prism. Now the last part of our today's class is to find the minimum angle of deviation for a prism. Minimum angle of deviation for a prism. So this is angle of deviation. You can rewind the video and check the equation, because this equation will need afterwards. I am just erasing it. Now we will find the minimum angle of deviation. Angle of deviation has different values, but for a prism, sometimes the angle of deviation becomes minimal, and we need to find that particular value of angle of deviation when the angle of deviation is minimal. So let us draw a prism. Let us draw a prism. Now we have to find the minimum angle of deviation. We know deviation means delta is equals to I1 plus I2 minus A. Now from this equation, what you can see, what are the factors on which angle of deviation depends? Factor on which delta depends is the only incidence angle. You can see, if we, from this equation, A is constant and I1 and I2 are depends on each other. So if we vary the incidence angle, I1 or I2 will change accordingly, but delta will remain same. A will remain same and delta will change with the incidence angle. So let us draw a graph showing the variation of delta with incidence angle. So here is a graph which represents the variation of delta. Say this y-axis is denoted or represented by delta. The delta is represented by the y-axis and the incidence angle is represented by the x-axis. So if we keep on varying I, we will have such a graph, a U-shaped graph, a symmetrically U-shaped graph. What is the significance of such a graph? The significance is that if we choose any delta, and for that we need to find two incidence angle, we can find for a particular value of delta we have two values of incident angles. For any particular value of delta we have two incidence angles for any particular value of this. Say that is delta 1, 2, that is delta 1 and we have different values of or you can write say I1 dash I2 dash. Corresponding to each delta there are two incidence angles. Why there are two incidence angles? It is very obvious, because there are two incidence angles. We have seen there are two incidence angles. One is here, I1, and one is here, I2. So for a particular delta, there are always two incidence angles, and these two incidence angles are represented or found in the graph also. But look, this is a particular value of delta where the value of delta is minimum. This is a minimum value of delta. So this is delta minimum, and for delta minimum we can find only one incidence angle instead of two incidence angles. Say this is I. So for minimum angle of deviation, these two angles will be same. What does it imply? It implies the refracted ray become parallel to the base. It implies that refracted ray become parallel to the base when delta is minimum. So for minimum deviation, these two angles will be same. It followed from the graph. Hence, what will be the value of delta? Delta min I1 plus I2 minus A. It will become I plus I minus A. Since both I1 and I2 are now same, so it will become 2I minus A. So delta minimum has a value 2I minus A. This is the minimum value of deviation for a prism. A is always the prism angle, and in case of minimum deviation, the most important thing is that the refracted ray become parallel to the base. So this is all about today's class. what we have learned? We have learned what is prism, how prism refracts light ray, monochromatic and polychromatic. Then we have found the amount of deviation while the light passing through the prism, and also we have found the minimum value of that deviation. So this is our content of today's class. In the next class, we'll do dispersion and human error. Thank you.